Hey there, this is Mr. Kern. These are the notes. This is Aaron. Say hi, Aaron. Hey, class. Hey. It'll be up on the internet. You'll be able to show your grandchildren. They'll be like, what's the internet? We use telekinesis now, which really isn't related to the internet necessarily, but we'll just go with it. Alright, this is the lab for reacting metals. So if you're not here on Friday, you're doing this or watching this at home, and you are filling out this sheet, which kind of gives you the rundown, but you're just writing your observations. So you're going to see some stuff happen, you write down what that is. When you get to the analysis, you pick out of everything you looked at, everything you noticed, some of the things you realize, okay, maybe that's not important. All of them did that. Some of them you realize are important. And so from there, you kind of pick which ones are the best to tell you if a metal is reactive. What makes a metal reactive, or how do you know? That's kind of up to you. Then you'll rank these from most to least, the ones listed on the front. So magnesium through, I'm pointing at the screen like you can see that. Magnesium through tin, all those you'll rank. And then you analyze your ranking. So talk about the top ones, talk about the bottom ones, talk about the copper, and all that. So on these, it's not questions that you will have a 100% correct answer. It's that you thought about it, you made a good argument, make a judgment, pull the trigger, write it down, explain it well. So don't have it not done when you come next time. Okay, so with this, what we did in class is we have these nice little metals, these samples of them. We're going to put each of them in a solution of copper sulfate. And so it's blue, that tells you it's got copper in it. Like if it were darker blue, it would mean it's a higher concentration of it. And so all we're going to do is just put these in here, look at how they react, and so make some observations. Then when we do this, we have to use some steel wool to clean off each sample, because some of them are so reactive that when they're just in the air, they will react with the air and get a coating of some oxide. So like you've seen, copper that gets green, that's copper oxide, or certain metals will rust. So all of them, even if you can't see it, have a little bit of that on the outside. So we have to use steel wool, get rid of it, then we'll put it in here. So basically I'm just kind of going to pause this, clean off a sample, put it in, and I'll show you what we're doing. Also, we'll keep track of the amount of time it takes on these things, just so you know how much time has elapsed. Looking for my mouse. There it is. So also on this, I think I legally have to say, I got this lab from a material science camp, which sounds, actually for me it sounds as exciting as it really was. You get to learn all kinds of cool labs. So if you're a teacher watching this, you should go here and look for, I guess, signing up for it. You get all kinds of free stuff. It was free to go to. I got this wonderful shirt, which I coincidentally wore today. Totally not planned. It's not funny, Aaron. Some kids. Okay, so I just cleaned off the magnesium. So that's the first one. So just flop her in here and write down your observations. Oh, yeah. Started off all nice and shiny, like all the rest. I'll try to remember to show you before and after. So just writing down observations, what's going on. Okay, so now I'll get the next one ready now. Alright, next up we have some aluminum. So it starts off looking like aluminum. I'm like 90% sure I'm going to drop one of these on my computer. Which really is the only way I have not damaged my computer so far this year. I set my hand on fire today.
You did?
Yeah, it was exciting.
Okay.
Mm-hmm. Okay, that's aluminum. Yay, aluminum. Ah. Alright, now we have iron. It doesn't start off as shiny as the others. It's kind of glossy a little bit, but it keeps some of its dark color. Now, even with cleaning these, you do still get some of the oxidation, just even between using the steel wool to clean it and putting it in the solution. So there still might be some things that are on the outside. So some of these that you'll see may start off really slow, and then by the time that you look at them later, they'll have a lot going on them. The other benefit is with you watching a video is you're able to later on look at each metal, rewind it, and compare what it looks like in 10 minutes to what it looks like now. And so in a class you don't get to do that. You can't rewind. Alright, next up we have some zinc. Starts off shiny like everything else. Now to compare at this point, because it's been, I don't know, maybe 5 or 10 minutes since I started the magnesium, so that's what the magnesium's doing right now. The aluminum is doing a bit more than it was earlier. The iron was just a couple minutes ago. And I'm hoping you can see color on this a little bit better than I'm able to see on my screen. Probably because my screen's really tilted down. Alright, so next up we'll do lead. Alright, so lead starts off nice and shiny too. Okay, that's lead. Alright, so the last one is tin. So starts off shiny. Yay, shiny. This really has to be one of the most riveting videos on the internet once it gets on the internet. Okay, so a recap on these. We've got the magnesium. We have aluminum. Iron. Oh, where is it? Zinc. Lead. And tin. Alright, so pause it here, give it about 5 minutes, then we'll check back on. Alright, so about 5 minutes later, magnesium, aluminum, iron, zinc, lead, and tin. Alright, a few minutes later, magnesium, aluminum, iron. And I can't remember if I said last time, I did this to go back in time and compare these containers, these vials, to the original ones, see how they look different. And then, set this up earlier today, like 2 hours ago.
Mr. Johnson, you have a phone call line 2.
Mr. Johnson has a phone call. And so these are what happened in about 2 hours. So magnesium, aluminum, iron, zinc, lead, and tin. Okay, so finish the worksheet, analyze these things. Oh wait, what about copper, you ask? Because that was one of the things you have to rank. So where's the copper? We have all these other metals. Copper is in the copper sulfate, so copper is in every single one of these. So what we talk about when we talk about if a metal is reactive, we're talking about the metal, not the ion floating around. So you have to kind of deduce where copper would go in this. And so, again, this is kind of your argument. Do you think copper is really reactive or not very reactive based on the idea of whatever you think is happening inside these containers? So where do you think copper metal would relate just because of copper being in the copper sulfate that all these were in? Make sure as you're going through these things, like I'm looking for on this, I'm assuming you're doing it kind of individually. So I shouldn't have like 10 worksheets with all the same answers because you should not have the same answers. This is kind of your own personal argument about what's happening and using what we've talked about and what you know about metals and reactions. So, yeah, have fun. I'll see you later.